Today, we're jumping into something that sounds like it's straight out of a medical thriller. We're talking about a story of muscles that just stop. Suddenly and with zero warning, they refuse to obey. Let's get into the really fascinating and kind of wild world of periodic paralysis. I mean, just imagine this for a second. You wake up. Your mind is totally alert. You can hear, you can see, but you can't move. Not a single muscle. It is an absolutely terrifying thought, right? Well, for some people, this isn't a nightmare. It's a recurring reality. So what in the world is going on? Well, this is a condition called periodic paralysis. It's basically a group of super rare inherited disorders, and they fall under a category called channelopathies, which, yeah, is a fancy word. All it really means is that there's a problem with the tiny electrical pathways in our muscle cells. And when I say rare, I really mean it. We're talking about roughly 1 person in every 100,000. So you can imagine, what does an attack like this actually feel like? Okay, so for section 1, let's talk about that first experience. For someone going through their first attack, the feeling is, well, it's just completely baffling. You go to bed totally normal, and then you wake up frozen. The really wild part is that these attacks are temporary. I mean, they can be super brief, just a few minutes, or they can drag on for several agonizing days, and then, poof, just as mysteriously as it started, the paralysis is gone. Full strength comes back, but it leaves you with this huge question. What is actually going wrong inside the body to make this happen? All right, to figure that out, we have to zoom in, and I mean way in. We're going from the scale of the human body all the way down to the microscopic surface of a single muscle cell. Okay, so picture your muscle cells. On the surface of every single one, there are millions of these tiny microscopic gates. That's the best way to think of them. They're technically called ion channels, and their whole job is to control the flow of charged particles. You know, things like sodium, potassium, and calcium. That flow is what creates the little electrical zap that tells your muscles to contract. Now, in a healthy person, these gates are like perfect little machines. They open and close with Swiss watch precision. Ions rush in, ions rush out, and you get that perfect electrical spark to make a muscle move. Simple. But in periodic paralysis, there's a genetic hiccup, a defect, and it means some of these gates are faulty. They might get stuck open, or they might leak when they're supposed to be sealed shut. Either way, that critical electrical signal gets totally messed up. And when that happens, when that signal is disrupted, the whole delicate electrical balance of the muscle cell is thrown off. The cell actually loses its charge. It becomes what scientists call electrically inexcitable. And what that means for the person is that the muscle simply cannot respond to the brain's command to move. The result? Paralysis. Okay, but here's where the real detective work kicks in. Because it turns out not all these faulty gates are broken in the same way. And the number one clue that helps doctors figure out what's going on, it all comes down to one single crucial element: potassium. So you can basically divide the main types based on what's happening with potassium levels during an attack. Let's look at this. First, you've got hypokalemic. Hypo meaning low. Here, attacks are triggered when blood potassium drops too low. You can see the genes involved, and the triggers are kind of surprising. Things like a high-carb meal or even just resting after a workout. Then, on the complete flip side, you have hyperkalemic. Hyper meaning high. And you guessed it, attacks happen when potassium levels get too high. This can be triggered by eating potassium-rich foods or even something as simple as getting cold. And then there's this other really rare one, Anderson to Will syndrome, where potassium can swing either way. That hyperkalemic form, the high potassium one, often comes with this really unique telltale sign. It's called myotonia. It's basically a kind of muscle stiffness. So for example, if you make a really tight fist, you'd find it's hard to quickly relax and open your hand back up. It can also happen around the eyes. It's a huge clue for doctors. And that Anderson-Towel syndrome? It's even more complex. It's really defined by this classic triad, 3 key things. You get the periodic paralysis attacks, number 1, but you also get heart rhythm problems or arrhythmias, number 2,
And number 3, sometimes there are distinctive physical features. This really makes it a multi-system disorder, which means it needs some very, very careful management. So you've got all these different types and all these weird triggers. How on earth do doctors crack the case and figure out exactly which cellular gates are misfiring? Well, it's a very clear step-by-step process. First, you start with the patient's story, a detailed clinical history. What seems to trigger the attacks? Next, and this is absolutely critical, you have to measure potassium levels while an attack is happening. There's also a special EMG test called a long exercise test that can show a very specific drop in muscle response. But the real gold standard, the thing that seals the deal, is the genetic test. That's what confirms the specific faulty gene.
And let me tell you, getting that diagnosis right is everything. I mean, it's absolutely crucial because the treatments are polar opposites. Think about it. For a low potassium attack, what do? You give potassium. Makes sense. But for a high potassium attack, you have to do the complete opposite. You give things like glucose and insulin to push that potassium out of the blood and back into the cells. Giving the wrong one, yeah, that could be incredibly dangerous.
So, okay, the mystery is solved. You have a diagnosis. What does life look like now? How do you even begin to manage a condition where your own body can basically turn on you at any moment?
The name of the game is prevention. It's all about being proactive. That means figuring out your personal triggers and avoiding them like the plague. For someone with the hypo-K form, that might be a low-carb diet. For someone with hyper-K, it's a low-potassium diet. There are also daily medications like acetazolamide that can help keep those ion channels stable. And of course, for anyone with Anderson-Tawil, regular cardiac monitoring is an absolute must. Now, the good news here is that with all this careful management, the outlook is generally really good. Life expectancy is totally normal. But, and this is an important but, over many, many years, some people can develop a bit of permanent muscle weakness that gets worse over time. And that just makes getting that early diagnosis and sticking with the treatment plan all the more important. So, what's on the horizon? What does the future hold? Well, this is the exciting part. Researchers aren't just content with managing the symptoms. They're hunting for a cure. You've got this cutting-edge research looking at gene therapies, things like CRISPR-Cas9, with the absolutely mind-blowing goal of going right into the genetic code and fixing the single typo that causes these gates to go haywire. Just amazing. And that just leaves us with this incredible, powerful question. Instead of just treating the symptoms, could we one day design a kind of molecular master key, one that could unlock and fix these faulty gates for good? It's a future that offers so much hope for everyone living with this incredibly rare and challenging condition.